In this video, we're going to take a look at a way we can transform quadratic functions, namely by changing the c value when it's written in standard form. Remember, standard form for a quadratic equation is f of x is equal to ax squared plus bx plus c. And that c I'm referring to is right here. Remember that c is also the y-intercept, and that will come into play as we start looking at what exactly is going on when we change that c value. Okay, so first thing we're going to do is, it turns out, and how we're going to look at these graphs is, we're going to assume that b is 0 here, so we don't have that middle term. And to start with, we're going to assume that a is also 1. So we would just have the function x squared plus c. Well, if we have something that's in that form, then what we're going to have and what's going to happen is that if c is greater than 0, the graph, the vertex of that graph, is going to be moved up that number of units. So if it's 5, for example, then it's going to be moved up 5. If the c value is less than 0, we're going to be moved down that many units. So, for example, if it's -3, that means we're going down 3. Now, I'm going to show you a little demonstration here, and this is on abettercalculator.com. You can also get there via this website right here. I thank them for creating such a wonderful graphing calculator. I use it all the time, and I just wanted to share it with you. What I've put together is the function that we're interested in right here, x squared plus c, and I've chosen to create a slider for c so that we can look and see what happens exactly as that value changes. So what we said was that if the value of c is greater than 0, the graph should move up. Okay, well, let's take a look. So as it sits right now, it's just the function x squared. If the value of c gets larger than 0, it should move up. So let's check. There we go. It's moving on up. Notice that the shape of the graph stays exactly the same, but it just moves up. Okay, so when it was greater than 0, we moved up. Now, the other thing that we said was that if c is less than 0, the graph's going to move down. So let's try that. Oh, here we go, moving on down. So, and we notice the graph, the shape does not change. Merely the vertex is what's changing. So that's what happens when we have that c changing. Okay, so now let's use that information along with what we also know about the a value of a graph and what happens if that changes. And just to quickly review that, remember that if the absolute value of a is greater than 1, the graph gets narrower. So I don't have a lot of room here, so I'll write NAR for narrower. If the absolute value of a is less than 1, so a fraction or a decimal usually, it will get wider. Okay, so let's use those two things to help us understand what exactly is happening in each of the quadratic functions here that we see. And we're going to compare them all to the parent function, which would be just f of x equals x squared. Okay, so let's take a look at what's happened in each of these, and we can talk about what's changed. So what's the difference between these two? Well, it appears we've got our a value, which is 5. So what is that going to do to the graph? Well, that's going to make it narrower because it's larger than 1. So it's going to be narrower, and that's due to that 5 on the 5x. And what else is different? Well, this plus 10 here. what's that plus 10 going to do? That's going to move it up. Okay, moved up. Exactly how far up? Well, 10 units. So it's moved up 10 units, and that's because of that plus 10 which is sitting there. Okay, so we can use what we know to look at the equation before we even think about graphing and get a good idea what it should look like, and that can be really handy as we look for errors and try to prevent errors as we're graphing these things. Also very handy in terms of comparing these things. Okay, so let's take a look at this one. Well, notice again what the difference is between these two. And the first thing I notice is that the coefficient is negative. Well, what happens if the coefficient of the squared term is negative? It gets reflected, so it's going to be opening down. This one opens down. Okay, and that's due to the negative right there. Also, we know with that 3 that it's going to be narrower because that's greater than 1. It's narrower because of the 3. And finally, we know that it's moved up 8 because the C value is plus 8. So, moved up 8. And that's due to the plus 8 there. Okay, let's take a look at another one. Making our way through these here. This next one, what do we notice for differences? Well, again, this one's negative, so that's going to open down. Okay, because of the negative, remember that makes them open down. This one has a fraction, so what does that mean? Well, if we look here, absolute value of a is less than 1. That would be true, so that's going to open up wider. And again, we're comparing them to that parent function right here. So this one's going to be wider because of that 1/2. And finally, it's going to be moved down 4 because this is less than 0. So we're going down 4. Okay, one last one here. For this one, we have the changes that we notice. Well, look here, we've got a 6. So what's that mean? Well, that's larger than 1, so the graph's going to be narrower than the parent. Okay, and that's because of that 6 sitting there. It's positive, so it's not going to open down, it's going to open up just like the parent. And this right here, this plus 1/2, well, don't be confused. Notice the difference here. Here it was the A, here it's the C. So since it's plus, that means we're going to be going up 1/2 of a unit. So we're going up 1/2, and that is due to that plus 1/2 that's sitting there. Okay, so transforming a quadratic function by changing the C, and also we took a look at the A stuff here. So I'll just tack on a and A sometimes. Remember what happens is if the C value is larger than 0, then we're going to be moving that vertex up, and if the C value is less than 0, we're going to be moving it on down. Also, don't forget those what happens when we change those A values. If the absolute value of A is larger than 1, the graph gets narrower, and if the absolute value is less than 1, the graph gets wider. Again, thank you to the team from abettercalculator.com, Desmos there, for creating this fabulous calculator. If you're interested in playing around with this particular graph that I've set up, I've got it saved for you. You can access it directly via this link right here, the second one. You can access that exact graph and play around and see what's happening. Also remember, abettercalculator.com will get you to that calculator, which you can play around with for all your graphing needs in your math classes. Hope this video was helpful. Keep working hard on your math. You can do it.